So hello guys, today we will discuss about supernetting. So what is supernet? So supernetting, this is aggregating networks together from a larger network. So the main purpose of supernetting is to reduce the size of the routing table on the routers. So basically what it does is that it saves the memory and processing resources on mainly routing devices. So that's why it results to lesser space. So the procedures in supernetting is one is we have to determine the number of the networks or IP addresses to be summarized. Number two is we will take the increment that is nearest or equal to the number of networks or IP addresses. And three, we have to get the range of the summarized networks or IP addresses. The fourth step is to determine the new subnet mask. And the last is to get the address. So here are some of the examples. For our first example is the network range of 201.42.14.16 to 23. The first step is to determine the number of networks. So we have to subtract 23, which is the largest of that range, to the lowest, which is 16, which yields us 7. So our number of networks is 8. Take note of the additional 1. We have to add 1 because we have to include the initial value. So it yielded us 8 networks. Then we have to determine the increment. So you have to take note that we have 8 networks. So therefore, our increment is 8 because it says here from the second step, the increment has to be near or equal to the number of networks, which is 8. So the increment is obviously 8. So we have to get the ranges. Our first range is from 0 to 7. Our second range is from 8 to 15, and our third range is from 16 to 23. So the example, from the given example, we have the third range. The example is to be found on the third range, which is from 16 to 23. So hence, the range to be summarized is from 201.42.114.16 to 23. Then the next step is to get the subnet mask, the new subnet mask. To do this is we have to determine what octet those numbers change. In this case, we have on the fourth octet. So our next step is to determine what number or what octets didn't change, and then we have to write 8. So in this case, on the first 3 octets, the numbers didn't change. And on the fourth octet, the numbers did change, so we have to leave a blank. Therefore, to determine the new subnet mask, we have to add those 8s together and the 5. So why is it 5? So from the increments, you have to count on what increment or where 8 is. So 8 is actually the fifth number from the left. So we have to add 5. So 8 plus 8 plus 8 plus 5 is equal to 29. So our supernetted network address is 21.42.14.16/29. For our second example, we have a network range of 71.0.64.0 up to 71.0.95.0. So we have to determine the number of networks, which is 95 minus 64, which gives us 31. And then again, we have to add 1, which results to 32 networks. So what is the increment? So of course, if there are 32 networks, what's the nearest number to 32? Of course, it's 32. So our increment is 32. Then we have to get the range of the summarized networks. So to do this, since we have an increment of 32, our first range is from 0 to 31. Our second range is from 32 to 63. And our third range is from 64 to 95. As you can see, the given example is on the third range from 64 to 95. Hence, the summarized range is 64 to 95. So we have to determine the new subnet mask. So as you can see, the number changed from the third octet. So it gives us 8 plus 8, and we have to leave blank on the third octet. So we have 19. So why is it 19? Because the number 32 is the third number from the left. So we have to add 3, which yielded to 19. So our supernetted network address is 71.0.64.0/19. That's it. So for our third example, we have a network range of 168.24.62.0 up to 168.24.131.0. So we then need to subtract 131 to 62. Rather, we have to subtract 62 from 131, which yielded 69. Then we have to add 1, since we have to include the initial value of the networks. That means we have the 70 number of networks. So from that, we have a network increment of 64 or 128. It depends. What increment should we consider? So first and foremost, if we chose 64 as an increment, the result would be an insufficient number of ranges, which won't include 62 or 131 at all. So we have again to repeat the process. We have to supernet those ranges that doesn't include on the summarized network ranges. But if we chose the 128, it will cover, or it will supersede the number of ranges, and that would be more complicated. So we chose, in this case, is 64. So hence, I tilted that from the given example, most of its ranges is from the second slice of these networks. So which leaves a gap of a network range from 62 to 64, as well as a gap of 127 to 131. But we have to set it aside, and we have to consider the second IP addresses or IP ranges, which is from 64 to 127. So we have to determine the new subnet mask, which is from the third octet. So it gives us 18 because 64 is the second number to the left. So which gives us a new subnet mask of 18. So our supernetted network addresses are 168.24.64.0/18. But again, we have to repeat the process from 62 to 64, as well as from 127 to 131, which yields 168.24.62.0/23, as well as 168.24.128.0/22. So these three are our supernetted network addresses. So that's all, and thank you.